we're going to talk about now what the second derivative can measure and what that looks like on the graph. So what we want to talk about is if we're given y equals f prime of x, and y equals f prime of x, and what f prime of x looks like. F prime of x gives us information about slopes of tangent lines. And with that information, it can give us information about whether or not f is increasing or decreasing, going uphill or downhill. The second derivative gives us information about concavity. And we talked about concave up and concave down before. And so what we're going to look at today is why does the second derivative give us that information? So let's first look at concave up. And when a graph is concave up, we might have two different types of pictures. We might have something that looks like that, or we might have something that looks like that. And in both situations, the cup is opening upward is one way of looking at it. But what we want to look at is if we're looking at slopes of the tangent lines. Oops, it's supposed to be a tangent line. What is going on with the values of the slopes of the tangent line? Because this second derivative gives us how much is the first derivative changing. Rates of change of f prime. So how are the slopes of the tangent lines changing? And in this one, where all of these are positively sloped tangent lines, and they are getting steeper. And for positively sloped, they are getting bigger, the slopes of the tangent lines. So we might start at maybe 1, a slope of 1, 3, 5. The numbers are getting bigger. This one, people might get mixed up on this because we're getting less steep. But if we think about, we're starting from a really negative number for our slope, like maybe this might be maybe negative 11. And then we're getting to be maybe at negative 1. So we're going from really negative numbers to not so negative numbers. In other words, we're going from left to right on our number line. And in both of these instances, f prime is increasing. Our slopes of tangent lines, which is f prime, is increasing. So that tells us that when something is increasing, it tells you its derivative is positive. So concave up gives us information that f double prime is positive. On the flip side, if f double prime is positive, we know that the graph is concave up on that part. Now let's look at concave down. You might be able to guess the punchline, but let's look at the pictures involved. Let me make sure this is completely separate. Okay. For concave down, we have, again, two different types of pictures. We might have something that looks like this or something that looks like this. And in these situations, thinking about what is going on with the derivatives, in other words, the slopes of the tangent lines, can make a little more sense of what is going on with the second derivative. For this one, all of these slopes are negative. And we're going from not so steep to really steep. And in this case, that means not so negative numbers to really negative numbers. Maybe starting off at -1 if we're thinking on the number line to -10. So we're going this way as far as the values of the slopes. Here, we're going from really positive slope, steep, positively sloped lines, so really high positive numbers, to not so high positive numbers. So here we have the slopes of the tangents, otherwise known as f prime. For both of these, they are decreasing. So this gives us f double prime is negative. So concave down, f double prime is negative. And one thing I should note, if you're looking at a perfectly straight line, no matter what the tilt is, lines have no concavity. That gives us that f double prime equals 0. Which means the slopes are not changing. Slopes are constant. That's what's special about lines. The slope always has a slope of 5. You might always be increasing, but you're always increasing at the same rate. So what we'll do is we'll practice this in some more examples. One thing that can help you remember, it can be silly, concave up is a smile, positive, right? Concave down, negative.